Chapter 2 of Curiosities of the Sky. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Roger Moline. Curiosities of the Sky by Garrett Serviss. Chapter 2. Star Clouds, Star Clusters, and Star Streams. In the preceding chapter we have seen something of the strangely complicated structure of the galaxy, or Milky Way. We now proceed to study more comprehensively that garlanded pathway of the gods. Judged by the eye alone, the Milky Way is one of the most delicately beautiful phenomena in the entire realm of nature. A shimmer of silvery gauze stretched across the sky. But studied in the light of its revelations, it is the most stupendous object presented to human ken. Let us consider, first, its appearance to ordinary vision. Its apparent position in the sky shifts according to the season. On a serene, cloudless summer evening, in the absence of the moon, whose light obscures it, one sees the galaxy spanning the heavens from north to southeast of the zenith like a phosphorescent arch. In early spring it forms a similar, but, upon the whole, less brilliant arch west of the zenith. Between spring and summer it lies like a long, faint twilight band along the northern horizon. At the beginning of winter it again forms an arch, this time spanning the sky from east to west, a little north of the zenith. These are its positions as viewed from the mean latitude of the United States. Even the beginner in star-gazing does not have to watch it throughout the year in order to be convinced that it is in reality a great circle extending entirely around the celestial sphere. We appear to be situated near its center, but its periphery is evidently far away in the depths of space. Although to the casual observer it seems but a delicate scarf of light, brighter in some places than in others, but hazy and indefinite at the best. Such is not its appearance to those who study it with care. They perceive that it is an organic whole, though marvelously complex in detail. The telescope shows that it consists of stars too faint and small through excess of distance to be separately visible. Of the 100,000,000 suns which some estimates have fixed as the probable population of the starry universe, the vast majority, at least 30 to 1, are included in this strange belt of misty light. But they are not uniformly distributed in it. On the contrary, they are arrayed in clusters, knots, bunches, clouds, and streams. The appearance is somewhat as if the galaxy consisted of innumerable swarms of silver-winged bees, more or less intermixed, some massed together, some crossing the paths of others, but all governed by a single purpose which leads them to encircle the region of space in which we are situated. From the beginning of the systematic study of the heavens, the fact has been recognized that the form of the Milky Way denotes the scheme of the sidereal system. At first it was thought that the shape of the system was that of a vast round disk, flat like a cheese, and filled with stars, our sun and his relatively few neighbors being placed near the center. According to this view, the galactic belt was an effect of perspective, for when looking in the direction of the plane of the disk, the eye ranged through an immense extension of stars which blended into a glimmering blur, surrounding us like a ring, while when looking out from the sides of the disk we saw but few stars, and in those directions the heavens appeared relatively blank. Finally, it was recognized that this theory did not correspond with the observed appearances, and it became evident that the Milky Way was not a mere effect of perspective, but an actual band of enormously distant stars, forming a circle about the sphere, the central opening of the ring, containing many scattered stars, being many times broader than the width of the ring itself. Our sun is one of the scattered stars in the central opening. As already remarked, the ring of the galaxy is very irregular, and in places it is partly broken. With its sinuous outline, its pendant sprays, its graceful and accordant curves, its bunching of masses, its occasional interstices, and the manifest order of a general plan governing the jumble of its details, it bears a remarkable resemblance to a garland, a fact which appears the more wonderful when we recall its composition. That an elm tree should trace the lines of beauty with its leafy and pendulous branches does not surprise us, but we can only gaze with growing amazement when we behold 100,000,000 suns imitating the form of a chaplet, and then we have to remember that this form furnishes the ground plan of the universe. As an indication of the extraordinary speculations to which the mystery of the Milky Way has given rise, a theory recently (1909) proposed by Professor George C. Comstock may be mentioned. Starting with the data, first, that the number of stars increases as the Milky Way is approached, and reaches a maximum in its plane, while on the other hand the number of nebulae is greatest outside the Milky Way, and increases with distance from it, and, second, that the Milky Way, although a complete ring, is broad and diffuse on one side through one half its course, that half alone containing nebulae, and relatively narrow and well defined on the opposite side. The author of this singular speculation avers that these facts can best be explained by supposing that the invisible universe consists of two interpenetrating parts, one of which is a chaos of indefinite extent, strewn with stars and nebulous dust, and the other a long, broad, but comparatively thin cluster of stars, including the sun as one of its central members. This flat star cluster is conceived to be moving edgewise through the chaos, and, according to Professor Comstock, it acts after the manner of a snow plow sweeping away the cosmic dust and piling it on either hand above and below the plane of the moving cluster. It thus forms a transparent rift, through which we see farther and command a view of more stars than through the intensified dust clouds on either hand. This rift is the Milky Way. The dust thrown aside toward the poles of the Milky Way is the substance of the nebulae which abound there. Ahead, where the front of the star plow is clearing the way, the chaos is nearer at hand, and consequently there the rift subtends a broader angle, and is filled with primordial dust, which, having been annexed by the vanguard of the star swarm, forms the nebulae seen only in that part of the Milky Way. But behind, the rift appears narrow, because there we look farther away between the dust clouds produced ages ago by the front of the plow, and no scattered dust remains in that part of the rift. In quoting an outline of this strikingly original theory, the present writer should not be understood as assenting to it. That it appears bizarre is not, in itself, a reason for rejecting it, when we are dealing with so problematical and enigmatical a subject as the Milky Way, but the serious objection is that the theory does not sufficiently accord with the observed phenomena. There is too much evidence that the Milky Way is an organic system, however fantastic its form, to permit the belief that it can only be a rift in chaotic clouds. As with every organism, we find that its parts are more or less clearly repeated in its ensemble. Among all the strange things that the Milky Way contains, there is nothing so extraordinary as itself. Every astronomer must many times have found himself marveling at it in those comparatively rare nights when it shows all its beauty and all its strangeness. In its great broken rifts, divisions, and spirals are found the gigantic prototypes of similar forms in its star clouds and clusters. As we have said, it determines the general shape of the whole sidereal system. Some of the brightest stars in the sky appear to hang like jewels suspended at the ends of tassels dropped from the galaxy. Among these pendants are the Pleiades and the Hyades. Orion, too, the mighty hunter, is caught in a loop of light thrown out from it. The majority of the great first magnitude stars seem related to it, as if they formed an inner ring inclined at an angle of some 20 degrees to its plane. Many of the long curves that set off from it on both sides are accompanied by corresponding curves of lucid stars. In a word, it offers every appearance of structural connection with the entire starry system. That the universe should have assumed the form of a wreath is certainly a matter for astonishment, but it would have been still more astonishing if it had been a cube, a rhomboid, or a dodecahedron, for then we should have had to suppose that something resembling the forces that shape crystals had acted upon the stars, and the difficulty of explaining the universe by the laws of gravitation would have been increased. From the Milky Way as a whole we pass to the vast clouds, swarms, and clusters of stars of which it is made up. It may be, as some astronomers hold, that most of the galactic stars are much smaller than the sun, so that their faintness is not due entirely to the effect of distance. Still, their intrinsic brilliance attests to their solar character, and considering their remoteness, which has been estimated at not less than 10,000 to 20,000 light years (a light year is equal to nearly 6,000,000 million miles), their actual masses cannot be extremely small. The minutest of them are entitled to be regarded as real suns, and they vary enormously in magnitude. The effects of their attractions upon one another can only be inferred from their clustering, because their relative movements are not apparent on account of the brevity of the observations that we can make. But imagine a being for whom a million years would be but as a flitting moment. To him the Milky Way would appear in a state of ceaseless agitation, swirling with a fury of whirlpool motion. The cloud-like aspect of large parts of the galaxy must always have attracted attention, even from naked-eye observers, but the true star clouds were first satisfactorily represented in Barnard's photographs. The resemblance to actual clouds is often startling. Some are close-packed and dense, like cumuli; some are wispy or mottled, like cirri. The rifts and modulations, as well as the general outlines, are the same as those of clouds of vapor or dust, and one notices also the characteristic thinning out at the edges. But we must beware of supposing that the component suns are thickly crowded as the particles forming an ordinary cloud. They look, indeed, as if they were matted together, because of the irradiation of light, but in reality millions and billions of miles separate each star from its neighbors. Nevertheless, they form real assemblages, whose members are far more closely related to one another than is our sun to the stars around him, and if we were in the Milky Way, the aspect of the nocturnal sky would be marvelously different from its present appearance. Stellar clouds are characteristic of the galaxy and are not found beyond its borders, except in the Magellanic Clouds of the southern hemisphere, which resembles detached portions of the Milky Way. These singular objects form as striking a peculiarity of the austral heavens as does the great coal sack described in Chapter 1. But it is their isolation that makes them so remarkable, for their composition is essentially galactic, and if they were included within its boundaries they would not appear more wonderful than many other parts of the Milky Way. Placed where they are, they look like masses fallen from the great stellar arch. They are full of nebulae and star clusters, and show striking evidences of spiral movement. Star swarms, which are also characteristic features of the galaxy, differ from star clouds very much in the way that their name would imply. That is, their component stars are so arranged, even when they are countless in number, that the idea of an exceedingly numerous assemblage rather than that of a cloud is impressed on the observer's mind. In a star swarm the separate members are distinguishable because they are either larger or nearer than the stars composing a cloud. A splendid example of a true star swarm is furnished by Chi Persei, in that part of the Milky Way which runs between the constellations Perseus and Cassiopeia. This swarm is much coarser than many others, and can be seen by the naked eye. In a small telescope it appears double, as if the suns composing it had divided into two parties which keep on their way side by side, with some commingling of their members where the skirts of the two companies come in contact. Smaller than either star clouds or star swarms, and differing from both in their organization, are star clusters. These, unlike the others, are found outside as well as inside the Milky Way, although they are more numerous inside its boundaries than elsewhere. The term star cluster is sometimes applied, though improperly, to assemblages which are rather groups, such, for instance, as the Pleiades. In their most characteristic aspect, star clusters are of a globular shape, globes of suns. A famous example of a globular star cluster, but one not included in the Milky Way, is the Great Cluster in Hercules. This is barely visible to the naked eye, but a small telescope shows its character, and in a large one it presents a marvelous spectacle. Photographs of such clusters are perhaps less effective than those of star clouds, because the central condensation of stars in them is so great that their light becomes blended in an undistinguishable blur. The beautiful effect of the incessant play of infinitesimal rays over the apparently compact surface of the cluster, as if it were a globe of the finest frosted silver shining in an electric beam, is also lost in a photograph. Still, even to the naked eye, looking directly at the cluster through a powerful telescope, the central part of the wonderful congregation seems almost a solid mass in which the stars are packed like the ice crystals in a snowball. The same question arises to the lips of every observer: how can they possibly have been brought into such a situation? The marvel does not grow less when we know that instead of being closely compacted, the stars of the cluster are probably separated by millions of miles, for we know that their distances apart are slight as compared with their remoteness from the earth. Sir William Herschel estimated their number to be about 14,000, but in fact they are uncountable. If we could view them from a point just within the edge of the assemblage, they would offer the appearance of a hollow hemisphere, emblazoned with stars of astonishing brilliancy, the nearby ones unparalleled in splendor by any celestial object known to us, while the more distant ones would resemble ordinary stars. An inhabitant of the cluster would not know, except by a process of ratiocination, that he was dwelling in a globular assemblage of suns. Only from a point far outside would their spherical arrangement become evident to the eye. Imagine 14,000 fire balloons with an approach to regularity in a spherical space, say 10 miles in diameter. There would be an average of less than 30 in every cubic mile, and it would be necessary to go to a considerable distance in order to see them as a globular aggregation, yet from a point sufficiently far away they would blend into a glowing ball. Photographs show even better than the best telescopic views that the great cluster is surrounded with a multitude of dispersed stars, suggestively arrayed in more or less curving lines, which radiate from the principal mass, with which their connection is manifest. These stars, situated outside the central sphere, look somewhat like vagrant bees buzzing around a dense swarm where the queen bee is sitting. Yet while there is so much to suggest the operation of central forces, bringing and keeping the members of the cluster together, the attentive observer is also impressed with the idea that the whole wonderful phenomenon may be the result of explosion. As soon as this thought seizes the mind, confirmation of it seems to be found in the appearance of the outlying stars, which could be as readily explained by the supposition that they have been blown apart as that they have flocked together toward a center. The probable fact that the stars constituting the cluster are very much smaller than our sun might be regarded as favoring the hypothesis of an explosion. Of their real size we know nothing, but, on the basis of an uncertain estimate of their parallax, it has been calculated that they may average 45,000 miles in diameter, something more than half the diameter of the planet Jupiter. Assuming the same mean density, 14,000 such stars might have been formed by the explosion of a body about twice the size of the Sun. This recalls the theory of Olbers, which has never been altogether abandoned or disproved, that the asteroids were formed by the explosion of a planet circulating between the orbits of Mars and Jupiter. The asteroids, whatever their manner of origin, form a ring around the Sun, but of course the explosion of a great independent body, not originally revolving about a superior center of gravitational force, would not result in the formation of a ring of small bodies, but rather of a dispersed mass of them. But back of any speculation of this kind lies the problem, at present insoluble. How could the explosion be produced? See the question of explosions in chapters 6 and 14. Then, on the other hand, we have the observation of Herschel, since abundantly confirmed, that space is unusually vacant in the immediate neighborhood of condensed star clusters and nebulae, which, as far as it goes, might be taken as an indication that the assembled stars had been drawn together by their mutual attractions, and that the tendency to aggregation is still bringing new members toward the cluster. But in that case there must have been an original condensation of stars at that point in space. This could probably have been produced by the coagulation of a great nebula into stellar nuclei, a process which seems now to be taking place in the Orion Nebula. A yet more remarkable globular star cluster exists in the southern hemisphere, Omega Centauri. In this case the central condensation of stars presents an almost uniform blaze of light. Like the Hercules cluster, that in Centaurus is surrounded with stars scattered over a broad field and showing an appearance of radial arrangement. In fact, except for its greater richness, Omega Centauri is an exact duplicate of its northern rival. Each appears to an imaginative spectator as a veritable city of suns. Mathematics shrinks from the task of disentangling the maze of motions in such an assemblage. It would seem that the chance of collisions is not to be neglected, and this idea finds a certain degree of confirmation in the appearance of temporary stars, which have more than once blazed out in, or close by, globular star clusters. This leads up to the notable fact, first established by Professor Bailey a few years ago, that such clusters are populous with variable stars. Omega Centauri and the Hercules cluster are especially remarkable in this respect. The variables found in them are all of short period, and the changes of light show a noteworthy tendency to uniformity. The first thought is that these phenomena must be due to collisions among the crowded stars, but if so, the encounters cannot be between the stars themselves, but probably between stars and meteor swarms revolving around them. Such periodic collisions might go on for ages without the meteors being exhausted by incorporation with the stars. This explanation appears all the more probable because one would naturally expect that flocks of meteors would abound in a close aggregation of stars. It is also consistent with Perrine's discovery, that the globular star clusters are powdered with minute stars strewn thickly among the brighter ones. In speaking of Professor Comstock's extraordinary theory of the Milky Way, the fact was mentioned that, broadly speaking, the nebulae are less numerous in the galactic belt than in the comparatively open spaces on either side of it, but that they are, nevertheless, abundant in the broader half of the Milky Way, which he designates as the front of the gigantic plough supposed to be forcing its way through the enveloping chaos. In and around the Sagittarius region the intermingling of nebulae and galactic star clouds and clusters is particularly remarkable. That there is a causal connection no thoughtful person can doubt. We are unable to get away from the evidence that a nebula is like a seed ground from which stars spring forth, or we may say that nebulae resemble clouds in whose bosom raindrops are forming. The wonderful aspect of the admixtures of nebulae and star clusters in Sagittarius has been described in Chapter 1. We now come to a still more extraordinary phenomenon of this kind, the Pleiades nebulae. The group of the Pleiades, although lying outside the main course of the galaxy, is connected with it by a faint loop, and is the scene of the most remarkable association of stars and nebulous matter known in the visible universe. The naked eye is unaware of the existence of nebulae in the Pleiades, or, at the best, merely suspects that there is something of the kind there, and even the most powerful telescopes are far from revealing the full wonder of the spectacle. But in photographs which had been exposed for many hours consecutively in order to accumulate the impression of the actinic rays, the revelation is stunning. The principal stars are seen surrounded by, and, as it were, drowned in, dense nebulous clouds of an unparalleled kind. The forms assumed by these clouds seem at first sight inexplicable. They look like fleeces, or perhaps more like splashes and daubs of luminous paint dashed carelessly from a brush. But closer inspection shows that they are to a large extent woven out of innumerable threads of filmy texture, and there are many indications of spiral tendencies. Each of the bright stars of the group, Alcyone, Merope, Maia, Electra, Taygeta, Atlas, is the focus of a dense fog, totally invisible, remember, alike to the naked eye and to the telescope, and these particular stars are veiled from sight behind the strange mists. Running in all directions across the relatively open spaces are nebulous wisps and streaks of the most curious forms. On some of the nebular lines, which are either straight throughout, or, if they change direction, do so at an angle, little stars are strung like beads. In one case 7 or 8 stars are thus aligned, and, as if to emphasize their dependence upon the chain which connects them, when it makes a slight bend the file of stars turns the same way. Many other star rows in the group suggest by their arrangements that they too were once strung upon similar threads which have now disappeared, leaving the stars spaced along their ancient tracks. We seem forced to the conclusion that there was a time when the Pleiades were embedded in a vast nebula resembling that of Orion, and that the cloud has now become so rare by gradual condensation into stars that the merest trace of it remains. And this would probably have escaped detection but for the remarkable actinic power of the radiant matter of which it consists. The richness of many of these faint nebulous masses in ultraviolet radiations, which are those that specifically affect the photographic plate, is the cause of the marvelous revelatory power of celestial photography. So the veritable unseen universe, as distinguished from the unseen universe of metaphysical speculation, is shown to us. A different kind of association between stars and nebulae is shown in some surprising photographic objects in the constellation Cygnus, where long, wispy nebulae, billions of miles in length, some of them looking like tresses streaming in a breeze, lie amid fields of stars which seem related to them. But the relation is of a most singular kind, for, notwithstanding the delicate structure of the long nebulae, they appear to act as barriers, causing the stars to heap themselves on one side. The stars are 2, 3, or 4 times as numerous on one side of the nebulae as on the other. These nebulae, as far as appearance goes, might be likened to rail fences or thin hedges against which the wind is driving drifts of powdery snow, which, while scattered plentifully all around, tends to bank itself on the leeward side of the obstruction. The imagination is at a loss to account for these extraordinary phenomena, yet there they are, faithfully giving us their images whenever the photographic plate is exposed to their radiations. Thus, the more we see of the universe with improved methods of observation, and the more we invent aids to human senses, each enabling us to penetrate a little deeper into the unseen, the greater becomes the mystery. The telescope carried us far; photography is carrying us still farther. But what as yet unimagined instrument will take us to the bottom, the top, and the end? And then, what hitherto untried power of thought will enable us to comprehend the meaning of it all? Chapter 3 Recording by Roger Malene